Okay, so on this question, we've got a function. And for this function, there are two important intervals, and a is a critical number. So first thing we got to do is we got to take this function down here and find the critical number. So how do we do that? Well, critical number is where f prime is 0 or infinity. That's a critical number. Critical number occurs where the derivative is 0 or infinity. So if I take the derivative, multiply this down, 6 multiplies 2/3. You can check that in a calculator. It's going to be 4. And the inside stays the same at first. Subtract 1 from the power. 2/3 minus 1 is minus 1/3. Then times the derivative of the inside, which is just 1. That's because of the chain rule. So there's the derivative. And we want to know where that derivative equals 0 or if it's undefined. Well, this really means 4 times 1, which is 4, and the x minus 3 goes to the denominator because it's negative power. Remember, negative powers jump to the denominator, then become positive? Okay. So basically, we want to know where this equals 0, and I'll say or, oops, equals 0 or infinity, right? Because a critical number is any place the derivative is 0 or infinity. Well, I don't know if you remember, how does like a fraction equal infinity? That's when the denominator is 0. Remember that? Remember, let me real quick review. 6 over 3 is 2. Just what is a fraction, right? Bottom goes into the top 2 times. That's why 6 over 3 is 2. Well, then by that same thinking, 0 in the top is going to be 0 because 4 goes into 0 0 times. But if you have 0 on the bottom, like say 7 over 0, how many times is bottom going to top, 0 going to 7? That's infinite. So you see 0 in the denominator is infinity. So basically the question is, can that denominator equals 0? Yeah. And that denominator, x minus, here, let me grab it with this, the denominator, just the denominator by itself, is going to equal 0 whenever x is 3. Yeah, I don't need to write anything, solve anything, just look at it. If x is 3, 3 minus 3 is 0. 0 to any power 0, denominator 0, and this thing's infinity, which means x equals 3 is the critical value. X equals 3 is the critical value. And they're asked us to find. And that's the answer you can see right there. So A is 3. That's the critical number. How'd I get it again? I took the first derivative and I said, where's it 0 or infinity? Well, if the denominator is 0, it's going to be infinity. And that's when x is 3. So x is 3 is the critical value. Okay, so we got that next. For each of the following intervals, tell whether it's increasing or decreasing. They want us to check before A is 3, remember, and after it. So we do a number line thing. So I'll go, okay, here we go. We're going to just pop 3 in the middle here. This is 3. And then they want us to check on the two sides of it. So I'm going to go, okay, oops, do that too straight, huh? So I'm going to come over here and go, okay, I'll check on something. Or let me do that a little better. I'm going to check x equals 0. I wrote 3. 0. You can do just 1 or 2. It doesn't matter. And I'll check x equals 4 here. I just like 0. Sometimes it makes things easy. Anyway, just something on the left, something on the right. Check what? Check what? Well, they said increasing or decreasing. What tells us that? First derivative. The first derivative is positive, it's increasing. First derivative is negative, it's decreasing. Right? It's all about the first derivative. So I'm going to check the first derivative. So what is f prime? Well, what is f prime? F prime is right there. It's 4x minus 3 to the negative 1/3. So that's the derivative. So we're going to plug into that derivative a 0. Pop in a 0. And let's go do it. 4, 0 minus 3 to the negative 1/3. 4, 0 minus 3 to the negative 1/3. So we come in here and we go, okay. 4, 0 minus 3 to the power Negative 1/3. There we go. Get negative 2.77. Negative 2.77. Okay, then over here, we're going to check f prime. Same thing, which it's going to be same thing, but this time we're plugging in 4. Let's go back and plug in 4. And I get positive 4. Positive 4. Okay, so what does that mean? That means in this section, it's decreasing. In this section, it's increasing. It's going up, going down. When the derivative is negative, it's decreasing. So we say it's decreasing in the first section, increasing in the second. Finally, they want us to say, is it concave up or down before A and after A? Concave up or down? Well, so we're going to do the same kind of test here. I'm just going to come in here and draw a line and do a fresh test. Now I'm wanting F double prime. Oops. F double prime because that's all about concavity. Here they're concave up is if F double prime is positive. Concave down is F double prime negative. So I can take second derivative. So let's take the second derivative of this function. So here we go. This minus 1/3 comes down. That'd be minus 4/3. X minus 3, subtract 1 from the power, minus 4/3. You can check on the fractions if you're a little rusty on that. You can check on all that. All right, so now I'm going to plug in x equals 0 to that. So minus 4/3. 0 minus 3 to the minus 4/3. Come down here, minus 4/3. 0 minus 3 to the power minus 4/3. There we go. What do we get? Negative 3.08. So I get negative 3.08. So that's concave down, like a bowl turned down. And over here, same F double prime. But this time, we're plugging in that x is 4. Right there, plug in 4. So plug in 4. And I get negative 1.333. So that's also concave down. So concave down in both parts. So down and down, concave down, concave down. And so there we go.